Good evening to all the faculty members and my dear friends. Myself Mahika Sharma, and today I am going to give a presentation of our project which is based on the topic OCR accuracy with image pre-processing using machine learning with Python. Under the guidance of Mr. Sanjeev Kumar Sir, Assistant Professor, Computer Science and Engineering Department. The success of our project is accomplished by me, Kritika Handa, and Rishika Jaiswal. So moving on to the next slide. We have the table of contents, which depicts what all topics we are going to cover in this entire presentation of our project, and I'm going to give you a brief and detail of all the topics that we are going to cover in this presentation in further slides. So, first of all, let me give you a brief of about what OCR is. So, optical character recognition or optical character reader, that is OCR, is a common and well-known technique, and it is the electronic conversion of typed or printed text to machine-readable text with optical scanner and specifically designed software. This software allows the computer to read different text images and convert them into dynamic and interesting data. OCR usually involves three steps. First, scanning, second, identification, and third, generating the output. That is, we are first going to scan a document in OCR software, then we will identify a document in software, and in the third step, we are going to produce the OCR output in the right format for you. An OCR engine is a software that recognizes the text in any given image. Widely used as a way to import data from printed documents, either it be passport documents, bank statements, business emails, computer receipts, static data transcripts, or any documents. It is a common way of making print documents digital to be editable, searchable, and carefully stored. OCR finds many applications in the fields of pattern recognition, artificial intelligence, and computer vision. The basic aim or the objective of our project is to convert any form of text or text containing documents such as handwritten text, printed or scanned text images into an editable digital format for deeper and further processing. The goal is to design and implement a machine using machine learning with Python. This is the technology we are going to use to implement our project because it gives more accurate results than OCR's pre-built machines that have been built with unique technologies such as MATLAB, artificial intelligence, neural networks, etc. The equipments or the tools that are used for that purpose are basically the cameras and the scanners. Handwritten text is scanned using a scanner. The image of the scrutinized document is processed using the program, that is the OCR system. This is the literature survey, which depicts that earlier OCR systems have also been developed, and they were different from the OCR system which we are going to develop, which we have developed. And these slides depict what all researches and works have been performed in earlier OCR systems. So moving on. Now we require a system that not only recognizes text and text containing documents such as handwritten text, printed or scanned text images and convert it into an editable digital format as said earlier, but also it supports multiple functionalities such as editing and searching. So basically we are going to develop a program, a software that allows the images to be edited and searched for. Now the proposed system for the problem statement is that we are mainly going to focus upon the accuracy at character level. That is, more accurately the characters are recognized, the better results will be produced and the less fixing will be on the word level. Now there are two ways of determining accuracies when it comes to OCR. First is accuracy at character level, second is accuracy at word level. Accuracy at character level is judged by how accurate an OCR software is on a character level. That is, how often a character is recognized correctly versus how often a character is recognized incorrectly. Whereas the accuracy at word level is recognized by fixing the word, that is finding the word inside the dictionary with the highest similarity. So the basic difference between these two accuracies, that is the accuracy at character level and word level, is that in character level accuracy, we can either count how many characters were detected correctly, and on the other hand, for word level accuracy, we can determine how many words were recognized correctly. The benefits of our proposed system is that first of all, it overcomes the drawback of the existing system, that is the limitation of the existing system which was proposed earlier is the recognition of documents of only a specific language like English. That is, the older OCR systems were unilingual, and our latest OCR system which we have developed, it provides additional functionalities such as editing and searching, and it also adds benefits by providing character level recognition as explained in the previous slide. This is the methodology, that is the steps that we are going to follow to implement our project. First step is input scan, then scaling to the right size, then increasing the contrast, then binarizing the image. After that, we will remove noise and then scan it, and then deskewing, and the last and the final step is layout analysis. In input scan, we are basically scanning, that is, we are basically trying to extract the input image which is free from any kind of marks, that is, it is not damaged, corroded, blotted, or printed in ink. The input image that we are trying to extract must be very clear, very clean. The text written in that input image must be understandable. That is what we are going in. That is what we are going to do in this step. Second step is scaling to the right size. In this step, we are basically scaling the original source image which we have obtained after step 1. We are scaling this input image to the correct size, which is usually at least 300 dpi. Dpi is the unit of measurement for these images, that is dots per inch. So having a dpi Next step is scaling to the right size. That is, we are going to scale the original source image to at least 300 dpi. This is the appropriate measurement for this. Next step is increase contrast. In this step, we are going to increase the contrast, that is the difference and the size between the text or image and the background. Fourth step is binarizing the image. Binarizing is an OCR reconstruction technique where grayscale colors and images can be converted to black and white or monochrome. The binarization process imposes a color image limit. In this binarization process only, thresholding is also a process that we are going to use, that is often used, and it is the process of converting a pixel color value to a minimum value when it is less than a limit, or a size if it is greater than the limit value. The benefit of this is that the image size is reduced before sending that input scanned image to the OCR system for further processing. Step 5 is remove noise and scanning. That is, we are going to remove all the noise, all types of disturbances in our input image, such as salt and pepper noise. For that purpose, we median filter. Median filter, it is a filter that is most commonly used to remove the salt and pepper noise, and the function used for the same is cv2.median blur. It computes the median of all the pixels under the kernel value, and the central pixel is replaced with this median value. This is how it works. Step 6 is deskew. Deskewing means it is the process of representing the text image in the right format and shape, and it can also be called as rotation. So sometimes it happens that any text image may not be in the correct orientation or position, or it may be aligned in some direction or angle. So to make the text horizontal at any angle, this can be achieved by rotating the text either in clockwise or anti-clockwise direction. Now, to summarize this step, we are going to recognize the block of text in the image. Then we will evaluate at which angle the text is inclined to, and then we are going to rotate the image in clockwise or in anti-clockwise direction to bring it to a proper orientation, that is in the horizontal direction. And the last and the final step is layout analysis or zone analysis. In this step, we are basically retrieving the output, that is the input source image that has been pre-processed using the above 6 steps will be retrieved in this step, and we can perform more functions such as searching and locating recognition sites in document images as well. Now the necessary packages to be installed for implementing the OCR system is Python version 3.5.2, Tesseract OCR 4.0.0, and PIP version 19.2.3. Additional packages to be installed are PyTesseract, CV2, and OS. Now these are the commands that we are going to use at various steps of pre-processing the input source image. And this is the command that we are going to give for displaying the output, which is mentioned at the 7th point. So these commands we are going to give in order to pre-process our input image. And I have attached some screenshots after working on the input images as depicted in figure 1, figure 3, and many more for your understanding. So to explain what difference to explain the difference between the input and the output image, I will explain the first two screenshots. Figure 1 depicts the input image one that I've taken, and it consists noise, it is very blurry, and the text in that image is not that much clear. Now after applying the steps of pre-processing, those 7 steps that I told you earlier, by giving the commands as depicted in the previous slides, I have obtained this output image, and you can see this is very clear, no noise is present in it, it is free from any disturbance, any marks, any noise. The document is very clean. This is what our system is going to do, that is OCR system is going to do, and the accuracy of this is much more than the input image. And these all are the screenshots of different images that I've worked upon by giving the output command, which I told you earlier, and I'm obtaining these very clean and accurate images as expected. So now I'm going to show you the implementation of my project. So this is the folder of OCR that I have created, and here are the input images. These all are the input images on which I have worked upon and obtained the output images for all these, and it has given successful results, very good results for all these images. So I'm going to show you for 1 or 2 images, and the procedure remains the same for other images. So here I'm going to type cmd, that is command prompt, and this is the command which I'm going to give to convert the input image to the output image, and I have copied it from there and pasting it here and press enter. So you can see that this is the input image and this is the output image. Input image consists some text and some noise in the background, which all has been removed by the OCR system, and the output is very clear. And the output is also printed here. That is, the text from that image is printed here, and we can use this text to edit and search for it on the internet. I'll show this working again for one more image. Let me take this one. Okay, so again I'm going to run the command. And I'm going to change the file name of this image. This image is named as example_05. So I am going to change the name of the image, otherwise it will not run for the image which I want it to run for, and then press enter. Now you can see the difference between the input and the output image. Input image consists of noise and some shading is also seen, and the output is very clear. And the text is also printed here. So likewise it will work for other images as well. So the efficiency of our project reaches 99% when taken into account all sample input images and their results. Thank you.